Hello and welcome. I'm hoping this is working. It should be live right now, live on stream. So, I'm back on Twitch because I just haven't been doing anything recently. So hello, welcome anyway, I'm Ginger Bill and today we're going to do some Odin compiler development. Specifically working on the new backend for Odin using the Tilde compiler backend, which is great. So I can probably just give a little bit of an overview of what is going on today and what I'm doing and such. And explain what is happening with Odin in this world. So, hello, welcome over to the chat. So before we do everything that, I have to kind of just post this in the correct places so people know what's happening. And hello, welcome to the chat. So where else do I put this thing? Maybe Twitter is a very good place to put this, I guess. So this stream now, we're only probably going on for about an hour or so at most, hour and a half maybe. Just because this is just a trial run to see what's happening. So we're just posting this where we need to go. So if you've got any questions, please feel free to ask all the questions. But yeah. Hello everyone in the chat, I can see loads of first time chats. It's wonderful, wonderful to come back. So, shall we explain what is going on with the new Odin compiler backend specifically? So let's share the screen, we'll see if this works. Yeah, there we go, it's working, that's great. I've got a new computer, so I had to set everything up from scratch. It's not the prettiest thing in the world. So yeah, let's carry on with this, shall we? So with Odin, we're looking at a brand new compiler backend is what we're trying to do. We're trying to not completely replace LLVM, but have a complete alternative to LLVM because LLVM is bad. Like, it is just bad. And buggy, and it just keeps breaking every version, and it's slow. Slow, buggy, bad, breaking, everything. It's just not, it's all the bees, all the bees. So we've been looking around, and sometimes people got a bit confused, so I wanted to just kind of settle things up. Originally, we were going to make our own custom backend. This was named, Graphite Master named it C0, which confused the heck out of everybody because everyone just got confused by the name. That officially, for the official Odin compiler, we're kind of abandoning, kind of. We're not doing that approach anymore. We're going straight with Tilde. So Tilde is the optimizing backend created for the quick C compiler, which is I'm showing right now here on the screen. And this was developed by Negate, and I'm going to be using the Tilde backend stuff here. So this is the Tilde compiler. It's an SSA based compiler, so similar to like LLVM, but it's a lot more, it's based off the work of like Click and many other things on top of this. It's a lot more advanced than LLVM in some ways, how it's been like learned from the past and what we're going on there. But then there's all the optimizer passes and many other things going on. So it's still being in development, obviously. So I'm going to be using it as it's being developed, obviously, which is fine. We're on a different branch. It's not going to affect anyone's like code when we use it in Odin. So it's going to be very nice to use, and we're going to hopefully, touch wood, be okay. So, yes, this is a stream, I know. I don't very often do these. Also, if you see me look like this, I'm reading this Twitch chat. Because the camera's there, the Twitch chat is there. Like, it's like a nearly completely 90 degrees. But yeah, it's fine. So yeah, I'm doing a stream. Hello, welcome. So yeah, I'm just talking about what we're doing now with the Odin class. I know this is a bit random. People say, oh, I'm streaming. What the heck is going on? I'm like, yeah, I know, right? So we're going to be doing this, and I'm just going to be showing the new Tilde stuff and working on this. So first, before I do that, merge in some, I mean merge. Yes, I did. So I'm just going to be making sure everything works. I'm going to make sure I've got everything up to date as well. Right, that's the wrong one. There's a lot of bunch of stuff here. Okay, so I've updated Quick as well and Tilde. And now as a broken thing, this doesn't work. Fine, that's fine. What do we do instead? I'm learning stuff because I've just updated and something that's not there. Brilliant start of the stream, isn't it? So this is kind of a... Oh, we've got a... PB Funk, param index. Not local yet, but that does need to be a pointer, I guess. So let's so I'm just going to get this working first before I get everything else. Compile. So people know what's going on, rather than me just randomly programming stuff. I'm like, well, what are you doing? Because this doesn't seem to work. I'm like, yeah, I know it doesn't work. So bear with, please. I think this is all this code actually was to begin with. So it should be. Okay. Yeah, we'll figure this out. I'll figure this out in a minute. I'll be fine. Just need to do that. So we got the address, which is the local. Let's say that's pointer. Param. Alignment is already got that there. No, it's not volatile. That should be okay. We need to get DT in there. No, that's not right. TB data type. Sorry, I'm just trying to get things working. So I've updated things as we go along. Does that work? No, I need to cast. Does that work? No. Need to cast again as well there? 2 casts? Then that's wrong. Was it not? Sorry, if you've got any questions, yeah. So recommend providing multiple quality options in the OBS transform as the stream is only available in 1080p. So yeah, I only am supporting 1080p because this is a 4K monitor. Yeah. I'm not sure if this is the best. And also, my upload speed is good, but I don't know if it's good enough. I have no idea. We'll find out. Right, so... So I'm just trying to figure out how to get this working, and I can't even remember how I wrote my own code. Oh, is it just... Oh, I don't even need the module in there. Okay, so I was right, it's just getting the type. And then we have an object file, because it needs to be cast to tbchar units. So once this is building, and kind of running, and now it says large int support to do. This is what happens when you update the compiler in the middle of a stream. It's like, whoopsie-daisy. Retry, where does this actually happen? So where does this fail, is my question. It says large integer support. Which function is this? The name is divmod. Yeah. What I'm going to do is cheat for the time being, just to get this compiling. Tilde Backend. There's the 128 one. Let's say that's just 64 for the time being. Who cares? This should still compile. I'm like, where's this gone wrong? Oh, for fuck's sake! I know where it's gone wrong. Sorry, and it's all this working on a compiler as it's being developed is always fun, right? Is that not working? What? Let's just pretend this actually is the case. And now it says it's failing somewhere. Do I use that elsewhere? No. Do I use this elsewhere? And the answer is I use it in a fuck ton of places. So sorry, I didn't mean to swear, but that's true. I do. Do that for the time being. It's all broken. Do I use it anywhere else? No, it should be fine. So, okay, for people who want to know, I'm actually working on Quick. Seems to be very early in development. Oh, I know it's very early in development. I am working with it. But it was further along development than what I was doing. So we're working on it because we want to get an LLVM alternative, obviously. Because if you don't have an LLVM alternative, oh god, it's going to be awful. It should be able to be an LLVM alternative in the long run. Yes, that is completely possible in the long run. Can I change my streaming settings as I'm streaming, by the way? Because this is one of those things where I don't know. Is it a bad idea to do this while I'm streaming? You believe. Okie dokes. I don't think I'm allowed. Okay, streaming bitrate 6,000. So the bitrate's not bad. Yeah, I can't. No. So you're getting to have to stuck with this 1080p loveliness. Say magnifique. Say it. Say, not just in French. But no, why is that? Where is that failing? We could just ask the debugger. No, you guys can't see the debugger. Great. How do I get this bigger? So if I go to 28, 28 there, and then 28 there, and that should be okay now. So you should be able to see this. So it's trying to. Am I gonna have to like unupdate the compiler to get this to work? Yeah. Might shouldn't have done this, but like. Where? Width is that, yeah. Yeah, that's not even existing. That's just because it's a macro, that's why. What am I doing wrong? Ah! What do you mean it's wrong? I've just done it right. Unless I have to... tb.raw. Okay. dt. dt is 168, okay. Yeah, because it says shouldn't equal that, but that's fine. It is that nowadays, isn't it? So... Oh, you moron, Bill. That'd be fine. That's fine. Now it's working all correctly. I had an assert which shouldn't need to be even existing anymore. That was all. Ignore me. Right. Let's figure this out. So it's showing what's going to happen. So you can see this code on the right here. It's not the best thing in the world. But this is not the actual code. Of course it is. This is a very well planned stream evening. It's just very impromptu today because I thought, you know what, I can stream this week, so I will do. What am I looking for? Entry windows. Right, the function we're compiling at the moment, this is what printing on here in this particular IR, is this function specifically, or just make it a little bit bigger for people. It's this. So this is the entry point for like a C-style entry point, where we have the parameters, we have the args, we're getting then slicing them and storing them to a global value. This doesn't work yet, but this does, that does, they all compile, and that does a return 0, but doesn't return the correct value yet, because I haven't got proper returns yet. I'll do that in a minute, okay? But yeah. So this is where it's going on, right, guys? So this is kind of what we're showing off. So the IR is just something, again, negated a few days ago, literally days ago. And this is something where we've got like, okay, this is rejecting the pointer, rejecting the value for the first argument. And then we're making a local variable called argc. And then we're storing that value into that pointer there. So we can then use this as a variable within the stack. This is just me hacking things in just to get them working. Yeah, makes sense. Then there is, this is another one with the argv. We're doing the exact same thing. So just defining these variables, no problem. Look, this is 4 bytes, and this is 8 bytes on the thingamabob, on whatever define. Now there was a different way of defining this printing thing, and he was doing it with graphviz, which was quite funny. The graphviz thing was like, instead of this IR, which I can read linearly, and the numbers aren't in order, by the way, it doesn't matter. I know how he's printing it. You can probably guess it's like it's because it's a graph dependency thing, but whatever. Let me see if I can get the graphviz, and it'll be fun. I know. This is a very impromptu stream, and I'm all over the place. But yeah, we can do all this. Then we're going to go look for the... we've got a load here, load there, so now we're using it correctly. So it's like a stupid store load that doesn't ever need to be used, and they'll just get constant fold when you do mem to reg anyway. Here's another bit of fence, whatever, ignore that fence. But this is the mem setting another pointer here. Where's this? Another local, whatever that's for. Doing arrays arithmetic. I know what I'm doing here, yeah. So this is just doing all this to calculate this bit here. So we're getting this multi-pointer and then slicing it into an array. So that big thing here, this is the slice it's generating. It's doing a array pointer offset, right? So it's taken the v4, which is the pointer, the argument itself, the argv. This is argv. And then we're doing offset of 0 and then stride of 8, but that's fine. And then we're going to store that into the first parameter there. So clearly this is doing nothing. This is a no op. But again, there's no optimizations on this little thing. I'm just trying to generate shit. The next one is going to be a pointer offset from the pointer to the one at 8 bytes. So that is now the length. We're then going to do a sign extension of the argc. And then we're going to make that into a parameter there. We're then going to sub 0 from it. Again, it does nothing because we're doing from the offset thing like that. Doesn't matter. Doesn't do anything, but that's great. It's just dumb IR. And then we're going to store this value into the length here. So now we've set up this slice. Then all we do here is we do a mem copy of that slice into the runtime args global, because that's what it is. It's the runtime args. That's all it is. Make sense so far? Yeah, graphviz was, even for the simple examples, was annoying, but like the way that Negate's written his is a lot more weird. It's the best way of putting it. And yeah, it was a very different way of looking at things. I was like, yeah, I understand why he's done it that way, but it's like it's not useful for anyone else. I'm just trying to show like I want to be able to read it down like it's assembly to a certain extent. So then we've got another thing going on here, which is defining a context variable. Obviously, it's defining the context now because it's not one in this scope, but now we have to define one. And then it's mem setting it to 0. This is then calling the default context, and it does nothing yet. We haven't even signed, and we can't even sign to it because this just returns void because I haven't done return values yet. What else is there? Then we got start runtime. We're going to call that, like, yep, and call it. Then we call the entry point, which is bug main in this particular case, and it is bug.main. Call the cleanup, and then we got that. And then we return. Now, there's no return 0 yet, which we should do. And that should be easy enough to do, is what I'm trying to say. So shall we try and add the return 0 at the end for us, just so it's not just blank. Where is it? Where are we going to? Oh, yeah, so end procedure. We haven't done the return statement yet, have we? Or have we? Return statement. No, we haven't. So let's see how we did it in the LLVM backend, because it's SSA based, so most of the code, not exactly, but return statement. Yeah, there's a lot of crap going on here. So let's look at how tilde statement return statement is, yeah, build the return, and it's empty. Isn't that wonderful? So all we need to do is figure out the return value, and we can get the type information from everything here. Is returned by pointer? We don't know yet, so let's just pretend it is. Return count 0. We can then just do return ourselves. So this will be tb inst ret. I think it's ret. We're going to find out. Yep, and it has a different number of returns as well. So let's just do 0 and null pointer. And now we have an empty ret there. That's lovely. The res count doesn't get used, but we can probably set this up. So we can have bb unused, do that. It's 1, that's fine. Else GP panic, multiple return values. Let's do that. That's where it gets a little bit complicated, but hopefully we don't hit any that requires that. I bet we will. But I hope we don't. I bet we will. Okay. So add a tuple to that list. We don't use. Yeah, it crashes. Wonderful, isn't it? So, it has side effects. Why is that has side effects? We could probably just do a 0 value here as well. So we could just do tb node 0. So this is like cg const nil, which should be a cg value. Yes. So that'd be fine. And then the return type is whatever that is. So tuple. I'm trying to think what this is. Tuple is variables 0. Type in there. So that's now the 0 value. And depending on how it gets passed, is it by pointer by or not, we'll figure it out, okay? So if 0 kind, if this is just an actual value as a register, we can return it. Otherwise, it's just going to be an empty return. 0, no, it's just 1. 0 dot value, node. What's wrong with this? Oh, CG value. There we go. So this doesn't even work. This is crashing. Why is that crashing? It's probably a null pointer again. Yeah, it is, but this return, that it's not liking me doing a return here. There's an extra return for some reason. So we can probably just test that quite easily because it's just, I've just got loads of debug code. Tilde to proc and proc, okay. If func, and then we want to look for the current control region, which is like a basic block in Tilde, by the way, if you want to know what that means. Control, so get the control. So if there is a control, then we can do it, but there might not be as soon as we've returned. Yeah, that's all we need to do. Because once we return, we're out that control block. So that's kind of what's happening here. And look, we've now got return 0, because we're just defining the 0 value, regardless of what is there. Which is great, by the way. It's good news. There's a result count, we don't need that. But yeah. Yeah. Good evening, good afternoon, good morning, whatever you want to call it. This is a very interesting stream. Obviously, me talking about nonsense because I don't even know what I'm talking about. Yeah, let's also make sure this goes up a little bit higher so I don't block any of the text. And you can see my face. Yeah. You want to see his face, right, for some reason? For some reason, I guess. I don't know. But yeah, so there's that. Now, if you've got any questions, please feel free to ask in the chat, obviously. It is always great to see it, obviously. And this is a pre-evening, afternoon, also known as that. That's a different name for it at times. But yeah, kind of little stream going on here. So I'm just getting stuff working, and this is the return stuff. Because the thing is, I can't just copy and paste the full-on return stuff from LLVM to Odin, because it doesn't really work that way. We can probably try and do so in places. At the moment, I'm just doing like 0 values. If I go back to the tilde statement and do the return statement here, This is fine if it's empty. If there is a value, we can do it. But let's just cheat, shall we? So entity e tuple variable 0. That's an entity. If the result count is empty, then we need to get the value from the multi return values to do it. But I'm going to just do the, you know what? I'm going to do that. Yeah. What else? Now, the other thing we need to do here is if it's not in that case, CG val. So CG in this prefix, like in the old LLVM, LB meant LLVM backend. CG in this means like, well, I thought it was called tilde, wasn't it? It's like, yeah, it means code gen. I just needed a better seat thing. I didn't want to use TB again because that's being used for the other library. So if you try and get different prefixes, you don't get confused up. So what made me pick up Quick specifically? So I was looking for different backends in general, and I was reading through the Tilde Backend that Negate was writing. And again, for people who don't know, the Tilde Backend is this wonderful thing here, which is made for the Quick compiler, C compiler. And it's a very fast, by the way, C compiler, and a very fast backend. And Tilde seemed like the best option. And the reason why this is kind of like, okay, why didn't I just go on what was already pre-existing? Or why wasn't I going with the one when I was making for myself? So there are a few options out there. So of the other optimizer backends that most people know of, there's libfirm, that somebody brought up in the chat earlier. There was also QBE. These weren't really options because they didn't even usually, how do I put it, they don't always meet all the requirements I want, even though saying they're meant to be mature backends at this point, or semi-mature. But also, with how they've been implemented, I've not got some, like QBE is a good example of this. QBE isn't meant to be as a library. It is meant just to be used as a, sorry, I'm just trying to think of what's way. QBE is not meant to be used as a library. You have to generate this textual IR that then you pass to its library. That's how it wants you to use it, which is just stupid. Like just stupid. Why? Is what I want to know. Yeah, welcome to that. Then there's the other problem with libfirm. Libfirm was another option I didn't want to go down because of the targets it didn't even actually support. Like, let me just doubly check with on here. Libfirm. Go back onto my screen here. Yeah, so libfirm supports x86 32-bit and Spark maturely, and I think it's still 64-bit one is experimental. Again, who give a damn about Spark? Seriously, who gives a damn about Spark? Really? And I know there's more on this. Oh, it'll tell you different stuff. And it's like, look, okay, so now we look what it compiles on. Oh, where's Windows? Where's Windows? Oh, yeah. People develop for POSIX, and it's like, oh, for God's sake. Can you stop doing this, please? But that's fine. Whatever. But also, these things weren't that great, and they weren't necessarily that fast either. And I've been looking through how Tilde works. And bless my face. And bless your faces too, obviously. But yes, the Tilde seems to be very, very well designed and also very well done. It's like, it seems to be very good in that regard. So like, okay, I know it's not complete yet, nowhere near done, but we can help develop it with the Odin compiler, obviously, and help improve the performance of this for ourselves, help everything get better and make it better. Which is kind of the point, if that's making any sense. Like, we're trying to do this. We're trying to make something better for ourselves. Like, we want an LLVM alternative. And I was going to speak in Negate. I asked him a feature the other day, and he actually implemented it, or is beginning to at least. And I was like, look, this would already make us better than LLVM, just as one feature in many ways. And one of them, I was going to explain it because we've now updated. I can probably do it, and that is generating the. You know what? Let's just show it. Let's just show it, not just explain it. It'd be easier. Yeah, so just reading the chat. Yeah, so libfirm, you did it is a research project, and you did it as a thesis using it, but to say it was much fun, wasn't that much fun, but it's still more than LLVM. Like, yeah, I agree, probably, but even then, ugh. So with, let's just go to LLVM ABI. This is the function, the file. It's only 1,500 lines, so it's not that big. It isn't, technically speaking, but it is insane. Like, there's no reason I should be writing this code, but I've had to. And to explain what I mean by this, this is the code which will generate, given like an Odin function, yeah, Odin procedure, function, what do you call it? Because I'm thinking of Tilde that's using functions. My brain's in different modes. An Odin procedure. How do you lower this to an LLVM signature, procedure signature, with the correct data types? So getting the ABI correct and getting the ABI for the platform, whatever it is. This is not something you can do because LLVM is quite schizophrenic when it comes to this design. It's tried to have, like initially at least, they're trying to get away from this now, but initially they were trying to have their the LLVM type system be like a subset of C. And they were trying to get a subset of C, but they didn't get it in all places. So like when you have like the LLVM functions, like function parameters, procedure parameters, these are actually kind of like pseudo-register things instead. So they don't actually follow the C calling convention. They're trying to be like, we've now got to figure out how do these actually get passed. And it's completely undocumented mess. So I've figured out a lot of it looking either look compilers or reverse engineering a lot. Most of it's reverse engineering. Trying to figure out how to do it. And if you look at how big the alone, I'm not joking, you said this was a 1500 file, right? 1500 line file, right? 500 of those lines are just for the system V ABI. So 1/3 of that entire file is just for system V. What? You say what? And this is one of those things where it's like, why isn't LLVM handling this for me? Like, honestly, why isn't it handling it for me? Like, and the argument may be like, oh, you may want a custom calling convention. You want to do things differently. It's like, great, but I don't even know how you pass these values on manually. Like, this is the funny thing is that the 500 lines of code that I've had to write here, it would be less code to write the manual assembly. And now I found out a few days ago, it was actually a few weeks ago, but it was making me laugh that apparently when people say about, oh, we need documentation about how to do all this, yeah, many people point to the Odin compiler and show you, hey, they've done it. This is how you can do it. It's like, wait, what? They're using my code that I wrote for the Odin compiler as the documentation for the API. Welcome to madness of LLVM. They don't bother documenting. They just say, go look at this code base. Oh, yeah. But now I asked this little feature for negate. Now, no, it's terrifying. It's not cool. It's terrifying. I asked a little feature for negate. So what I said to him is like, look, we are probably going to have to generate the debug information anyway for like function types, procedure types, their signatures, the prototypes, whatever you want to call them, right? And in a recent commit, let me just show you the commit. It's the wrong branch. Look at these commits. That was the latest one, but is that the right one? Yeah, so here's this one. It's still working. But the whole idea, I said, look, could you give us a debug type? Because we're going to need that just for debug information. And then from that, could you generate a, what's it called? Generate the correct function prototype, as he calls them, function like signature from that. And then when you've generated from that, hopefully things should go well, is what I'm trying to say. Yeah? Which is kind of like, look, it's more of a like, I want it, Tilde should be the thing handling the ABI, not us. And there's no reason why we should. Like, if we want to do something manual, sure. But it's still like SSA based, so it's not really technically like manual. Like, you can't really violate it going past its kind of conventions. So it's kind of you get in that middle ground. It's like, look, just be a bit higher level, please. Just handle the ABI for us. You only have to write it once, and then everybody else can benefit from it. Literally everybody else. And this is the thing, is you need to be about LLVM. That's one feature. It's going to be better than LLVM on already. Kind of. Not there yet. It's only doing Win64 ABI, but you know what I mean. This is what's the benefit of having a new thing, like helping develop it as it goes along with Tilde. And again, I recommend checking out Quick in general. Like just as a little, it's still in development obviously, but it's still like pretty cool. Like really, really cool what it is and how it works. And yeah. It's one of those. Rightio then. So I'm just looking at chat and other chats and all that lot. Fun days, isn't it? Right. So this is kind of the wonderful thing as I'm doing all this. Yeah. Am I meant to put this in other places? Sorry, just checking. Yeah, so probably only got another half an hour of this stream at least. I might come back again this evening, by the way. I might just do it later this evening, but I will have a break. But yeah, so what is Tilde? Sorry, Tilde is just this new backend that I'm integrating into Odin. It's still in development itself. It's like it's not actually that mature yet. But as the development goes in, we'll try and make it better. That's the whole point. We're just trying to make it better for both Odin and Tilde, so everything will be there. So that's one thing I'm talking about, the ABI stuff. I'm just trying to see if I can do what this is doing here. So CG build expression return results 0. Conversion. Hopefully this doesn't break anything. Type. And then we should be able to just return that. There is an internal thing. If res dot kind equals CG value, then we can actually just return this. Res.node and then return. Otherwise, we're just going to have to do blank after this because this is the annoying thing. I can't figure out how else to do it. It says result count. Oh yeah, because I got... Is it result count I wanted? Return count result. Bloody hell, I can't... No, wait. That's not right. It was result count. Res count, that's what I wanted. Yeah, so that's fine. Just to prove that this thing actually works and it's got a different return value, let's change this to 1. And it should say ret1. And it does. Look, just to prove it, let's go 137. Ta-da, it works. And that's actually good news that we know in this kind of code works. This is still mocking stuff out, by the way. So most of the commits at the moment on this branch are update tilde 20-bit types are broken, mock out CG return type. There we go. Rightio then, that's kind of fun. Now, so there's other things what we're going to do. So one thing is, luckily because of the LLVM kind of code base that we've already got, a lot of it does transfer because it's SSA based, which means we can kind of get around with it compared to what we've got. So the question is, which bits do we fill in and fill out is the best thing. There's all the statement shit, put it bluntly, but a lot of that's going to be difficult because I'm not sure how I'm going to handle multi-return values yet. And like multiple valued expressions. That's not something I've figured out because it's different to what we've got. And the way I was doing it in like LLVM was just a bit of a hack, but it had to be because of LLVM. So now it's not that, and we have a much saner system. It's kind of like, how am I going to redesign this? This is one of the beauties when you have a rewrite. You actually know all the problems you had before, and you can go, how do I design this differently? Like there are some things within Tilde which is very different. Like for instance, they don't use basic blocks. What it uses is control flow. And these control regions, and this is the technical term if you ever read like an SSA paper rather than a basic block. But these control regions are a little more, they're just nodes within the graph itself. They aren't actually like separate. Like LLVM keeps these basic blocks separate while these control nodes are all part of like all of the graph. And in this way, it actually makes things a little bit more flexible, a lot easier to deal with and such, and which is great. But it works pretty much like nearly 1-to-1, so you shouldn't really worry too much. Let's look at the expressions, I think, because there's a lot in... There's not everything we've filled in yet. Like we've got slicing work, like very basic slicing, which is kind of insane when I think about it. Like slices got in before... the selector expressions work, yeah, that's fine. They're not difficult. They're still being mocked out, but yeah. Oh yeah, that was what I wanted to work on. So I know it's scatterbrained today, but this is not planned. This is very impromptu. Struct, no. Is it in statement? yeah, this is still like a working like progress. Get struct field type. Yeah, I'm not a big fan of that old code. Let's just clean that old code because I copied and pasted it and that's just dreadful, to be honest with you. This is also like, this is just really dreadful code. So I'm going to just make it a big switch statement. So first off, do the exact same that it is. Type complex, let's do that. That's fine, just break there. We've got a quaternion thing going on as well. Quaternion, yep. Case type slice. Case type string. Okay, this is where things don't actually match because it's not technically the same thing, but that's a type isn't a string either. This is basic. And then switch, is it type? Yeah. T basic kind. So then we have type string in there. Anything else in there? Yeah, type any. No, type, not type, what am I doing? Basic string. Basic any. And what I'm going to do with this code is also put the offsets in there as well. So this would be case type dynamic array, because who else doesn't want a dynamic array in there? We get the map in there as well. Is that correct? Yeah, that's right. Type tuple. Yeah, Odin doesn't support tuples. So tuple is just a poorly named thing within the compiler. It's just the procedure parameters. Like, the way of describing this is if you have a procedure like this int float and it returns like an F64, like that, whatever it is. This is a tuple. That's a tuple because it technically could be multiple at the end as well. So it's called a tuple because I didn't know a better name to call it at the time. Like, we don't use tuples anywhere. They're not first class. They are only used as procedure parameter things. We just call it a tuple. So, yep. Someone with a question. Thank you for the first time chat as well. Loads of first time chats today, which is nice. Are you moving away LLVM? So the answer is kind of. So we're going to keep LLVM. We're probably going to keep it as the main backend, or at least it will be the optimizing backend in the future. And we're just trying to have an backend now to get away from LLVM. So because LLVM is slow. To give you a good example of how slow this is, DjangoFX on my machine, I have got top of the line hardware to compile with, right? It's got 16 cores, a new CPU, whatever. To build Embergen, which is about, it's a big project. Let's just say it's a big project, okay? So 200, I don't know how many hundred lines of line, a few hundred lines of code, okay? A few 100,000 lines of code, just say, be careful. On my machine, it takes, with the correct flags to make LLVM go faster and multi-threaded, goes 2.2 seconds. Yeah, 2.2 seconds. That sounds like it's really fast. Yeah, that's with pushing LLVM to be multi-threaded. If I take the multi-threading off, it goes to 5 seconds. Yeah, 5.5. In the 2.2 case, 90% of that time is LLVM in the linker. In the 50%, in like the 5.5 second case, that is 95, if not 95 to 98% of that is LLVM. That's how slow LLVM is and how fast the front end is for Odin. So with Tilde as the new backend, we could hypothetically get Embergen compiling in well below half a second. So imagine you've now got a few million lines of code compiling per second without caching. Without caching. Yeah, that's what we're trying to achieve because we know how fast computers are being. Like, why can't we do this? Like, oh, yeah, we should be able to get 2 million lines of code per second. Why shouldn't we? Compiled. Not just type check, compiled. computers are so fast, and like that sound might not even sound fast nowadays, but it's like, yeah, but we do a lot more than the older, like the dumber machines as well. Like we do more optimizations, we do better error messaging, more complicated things. It's not like it's a single pass compiler anymore. Like this is a multiple pass compiler because it's a multiple pass language, and it needs to be a multiple pass language. And loads of these oddities of like the older languages we can't really get anymore. This type, but yeah, there we go. Hopefully that answers some questions at least. Maybe not all of them. Yeah. Yeah, so TC, yeah, so we were originally going to have, I don't know, I'm not going to explain that here. Yeah, C compiler with TCC would also be about the same kind of, yeah. So, yeah, I wonder how does ASM output compare to LLVM? At the moment, Tilde, I think he's got to about the level of like compared to like Clang's 01. Which is good. It's not great though. It's not 02 level yet. And then it's not clear not 03. Like 03 I very ever use. It usually just gives me crap generation, even though it's been so aggressive. Like 02 is sometimes just better than 03. But like if we get to 02, like it's on par with LLVM then. Nearly. And it could be in the next couple years. Like not even joking. This is something where people think, oh, don't you know LLVM? That's had hundreds of people on it, working for 20 years and millions of dollars and pounds or whatever. You insert your currency here on it. It's like, yeah. It's also like wasn't well designed to begin with. Like it was a university project. It's got a lot of like sludge to it, and it's like, yeah, sure. Oh well. Yeah. So the coding project, I'm not technically related to that. So the C Odin just means it's another Odin compiler written in C. That's it. This is why people got confused with the namings. I should tell Graphite Master to never name things ever again. He just can't, oh God, just confuse people with his naming conventions. No. Don't do that. Yeah, this is the thing is, yeah, millions get spent on like Visual Studio. It's like, it doesn't mean it's actually any better. It isn't. It is funny to me that people think, oh, of course, there's like hundreds of people have worked on this and millions have gone into it. So therefore it must be good, right? That's just like a Labour theory of how like fallacy. Don't do that, please. It doesn't mean anything. It also means like that would also say that entrepreneurs couldn't ever do a better job than what's previously existed, which is like objectively false. Undeclared identifier. What? Where's the complex numbers? Oh no, the complex are built in. So are the quaternions. Yeah, I'm a moron. Let's just do that. I'm 128. Of course they are. This shows you how much the code was a bit crap, to be honest with you. Case basic quaternion 64. So it's a 64-bit quaternion. Then we got a 128-bit quaternion and 256. Like so. And I'm just going to do a default in this bit, just in case something never gets bought. And then also do this to make it okay. Yeah. And I'm not saying that LLVM is bad because it just is like, but it's just, there's a lot of technical debt you get things. If it's a 20-year-old project, of course you got technical debt and you can't get rid of it. But the thing is they keep breaking it as well. It's like, I could get on a rant with LLVM. I'm not going to, because I'm not going to stay on the stream for more than like, I'm going to rant for hours if I do this. So don't do this. Just put it this way. No, just we need an alternative LLVM and quick is all we're doing it. So we're going to use quick Tilde. Oh, that's a bad joke. But yes. Good oaks, there we go. So they've still got some. Yeah, there we go. There we go. Okay, that's fine. We probably do need the LLVM rant, but not right now. Okay, not right now. So one thing I'm going to do here is get struct field type. And it's like, well, we already do all this. So I don't know why I don't just do this. So if I just do, yeah, that's the result type. One thing I can do here is I can also just define the offset. I'll do -1 there just to make sure it's false. GB assert is greater than 0. Because if it is at that offset, that's great. That's not a problem. So then this is type struct offsets. That's the index. And then we can just do a where's the offsets? Set offsets, I guess. Let's just do that. Just make sure it hasn't been set already. That's going to be fine. This one's okay. So these are offsets as well. So offset. Offset. That's going to be whatever the int size is. So that's going to be build context int size. Yep. We could do. I'm just going to make that a little bit smaller. And pointer size, because we do make a distinction now in Odin between the int size and the pointer size, which is great because the whole point of this is this allows for us to maybe like detach the idea what I'll let you int separate from an int and a pointer, obviously the sizing of them, and allows you to do like pseudo architectures as well. A good example of this is eventually what we're going to do for the WASM backend is there's two WASM targets at the moment. There's WASM 32 and there's WASM 64 P32. So WASM 64 P32 is a pseudo architecture that doesn't exist. So what it does is it has 32-bit ints, sorry, 32-bit pointers, it's the P32 bit, but it's 64-bit ints. So the int is larger than the pointer. So you may be asking me like, why the heck have you done, why does this even exist? Well, there's actually like two main reasons for this. One, 64-bit pointers will be faster, and that's the more natural size on most of these like machines that run WASM nowadays. They're all 64-bit. But the second reason is it allows you to have the full 4 GB address space with signed numbers by default, signed integers by default, which may seem like, why didn't you just use unsigned? It's like, because there's a lot of cases where you really want signed and you want to be able to express the 4 GB and do the arithmetic in signed integers. So that's one of the reasons why. I'm not writing the LLVM turn. I don't need to. We're working with Tilde. Like, Negate's got it planned, man. We don't need to write a new one. Tilde's it. So we're happy there. So happy days is all I'm going to say. It could do the same thing with a string and a slice. They are effectively the same layout anyway. And an any is a little bit different because they're both pointers. So, whoops. The offset of that one is 0, but the offset of this one is pointer size because that's a pointer and that's a pointer, I think. Let me just check. Just checking to see what the size is of a type ID is all I'm checking. It is a pointer sized. So that means an any is only 2 pointers, so it's tinier actually. Ooh, okay. That's good to know. Actually, that's fine for a pointer. That's fine. These are slightly different. We could probably merge all this as well, but I'm not going to. So this is size, size of FT. And for all this code here, we could just keep it the same. Just do a default GB panic. We know what. I'm going to use a go-to. And the only reason I'm using a go-to is because it's just C++. Like I'd easily be able to do this in Odin, no problem. It's not the point. Offset is size times by the index. That would work, yeah. And then we can do the exact same thing here. we can probably just inline this. There's no point making the case not to do that. Okay, so this is where it gets a little bit more complicated because we've got a pointer and then yeah, that's fine. So we should actually, that's okay. Okay, so offset, that's at 0. That's at 1 times int size. That's at 2 times int size, and that's at 3 times the int size. Okay? This is where things get a little bit more annoying because we've now defined it as the struct, but the struct thing is this. I love my asserts because it's easy. It's just quick falling out through this. So like that, and that should be RMS for the raw map struct, not for the other chap. You know what I'm talking about, right? Right? I'm not going to explain myself after that, so that's okay. So this is the base integer. Okay, so a lot of these cases where they're clearly like this, these are all identical. There we go, the same here. Like that. They're different, they're different. Yeah, that's not unification, that's unification, that's fine. Yeah. I mean, let's just do that. It's a size here. Have we got that? No, but that is type size of. No, actually, let's not do that. Let's put it there. And then we have base integer, which is bi. And then we have go to error case. I've got a double default. Whoops. RMS. Oh, T raw map. Wonderful. Enjoying the keyboard sounds when they come through. What switches do I have? I have a. This needs a clean. It's a bit dusty. That's the problem. There you go. It's a black keyboard. All right, let's carry on. So we are keeping on with the struct get stuff, or ep. It's not what we're calling them in here, but like what happens with the geps is we haven't got this yet. It's still a to do, but I think what we can do, because now we've got the to do bit anyway, is to do that. Yeah, you won't be able to hear the keyboard because I should have some like noise gate stuff on there, so it should prevent it anyway from coming through. But yeah, so these are the result types, and they need to be a pointer to a result type after that as well. So if we go to the struct, is it struct? No, it'll be member access. There we go. Um, it is this, but I've already done this up top, but I'm doing it anyway just to prove that I've got it. P-Func, that is now the base. Yeah. And then we have an offset already. And then TV node. This is the pointer putter, I guess. And then we can just do CG value, the pointer. And then we have to have a pointer for the result type. Yeah. And we don't even need to do this. Because that... LLVM utility, I think it's under. No, it's not that. It's LB. There we go. It's doing like constant value checks. That's all we need. So yeah, that's fine. That's not even... Convert struct index. Yeah, we don't even have to worry about that anymore. Oh, isn't that wonderful? Because I just use the Odin stuff directly. And in fact, get rid of that variable. We can just do this on one line. And for the person who was asking, do I use 8 character wide tabs? Yes, yes, I do. When you're in like the size of the font I normally use, the 8 character wides don't make a difference. And yes, this is tiny. Yes, I would normally have 3 or even 4 scuff open because I'm just zooming in for you guys because you're on a stream. Yeah, it does get a little bit in the way. But it also prevents me from nesting too much because I don't know, I just like try not to do too much nesting if I can help it. So that offset should be greater than 0. That should be all fine. This should be working. I don't think I use it yet anyway, but I'm just mocking things out. If you didn't guess. Which is wonderful, to say the least. Do we have a member? So other questions I didn't see. Is the C backend still planned? Kind of no. Kind of no. There's a big kind of. Let's just say hypothetically we could get Tilde to work with a C backend, but we're not going to yet. There's no point. It's not a high priority. But yeah. Why did you decide to make Odin's syntax so much nicer than Zig's? Well, I made the syntax before Zig even knew about Zig, so... And Zig's syntax isn't that bad, really. So each their own, obviously, I guess. Yeah, I guess. And you're in this. Look. When I look over, you're that way. Apparently, I'm not. You're not like here, like looking at whatever. Yeah. Thank you for the nice compliment of Odin syntax, I guess. Yeah. Oh, so good question. Why is a string size 2 times the int size rather than an int plus pointer size? Padding. Because the int needs to be aligned to the int, which is going to be greater than or equal to the size of the pointer in this case. So because of that, you'll have padding between the pointer and the int. You're never going to have an int less than a pointer size. That's what's guaranteed with the Odin thing. And because of that distinction, you kind of need to make sure that you've got the right offset. That's why. So just to make sure people don't understand, let's say the pointer int thing, like, oh, let's say a string in Odin internally has this structure. It has the data, a multi-pointer with like a U8s in there, and then it has the length, which is an int. Now let's say we're on WASM 64 P32, or I haven't implemented this yet, Linux's X32 operating system. Like, right? These are different architectures. These are both pseudo architectures, but they're useful. So in these particular cases, the size of a pointer in these cases would be 4 bytes, yeah? But the size of an int would be 8, yeah? And just to make it clear to people what's going on as well, if I do the alignment of these, they're the same again. So this would mean, this would be the equivalent if I put a padding here of another 4 bytes as the padding, yeah? Yeah, that's the padding. So that would be equivalent on this system. So that's why it's equal to 2 times the size of an int. It's not equal to the size of an int plus a pointer because you've got padding to worry about. Make sense? Hopefully? Now we could have designed it so the int was before the length of the data pointer. I don't like that system. There's reasons why I didn't do that, and also it doesn't need to anyway. Like, we're doing it correctly. Hopefully that answers some people's questions. If so, nice. Good, again, thank you for the compliments. Odin syntax. Yep, syntax is not unimportant usually. So, yeah. There we go. Trying to explain all this. The deep get got easily implemented, but what you do is you just go through a big loop. So this is another one of these I can make into a switch statement. So switch type kind. Yep. So this is a case for that. I'm going to put a break there as well. Or put break inside, doesn't really make a difference. I have another case, but this is for the, this is where the basic becomes in. So case type basic and switch on type basic kind. And this is type quaternion. Yeah. It's broken, so it's to break there. Case type raw union is different to a struct. Yeah, of course it is, because they're all at the same offset. So this is actually just a shorthand for a struct. But then if it's a type struct raw union in there, yeah, we can then just do that lovely trick. Okay. Oh, so we can then just do the normal struct in a little bit time here. So there's the raw union case, and here's the struct. Let's do an actual union this time, which is an Odin union, for people that don't know. That's fine. Type tuple, not a real thing, just there for the time being. And then we've got the other basics here. We can then merge here. Yep. Wait, was that right? I'm going to undo all this code, just to see what I did wrong with the quaternion. Nope, nothing. Then we have the basics gone now, it's great. We got slice, so type slice dynamic array. Array. Oh no, array's got its own thing, so let's do that. Let's go for struct, not struct, map, I should say, goes to there. That's the same thing. And so does a relative pointer. And then default break there. Should be okay. Type quaternion isn't really a thing, nor is there actually even counting the structs or anything in there, but that's kind of a, we could just do a default for everything else as a catch-all, just except for the any, which doesn't even need braces around that. Don't know why the type is not being passed around each time. It should, but I guess it's because it doesn't ever get back again. I don't know. It is raw union, I guess. Yeah, it is. Look at my own code. Oh, that's wonderful. Wonderful. That's good. So that's just a bit of a cleanup of the code already. This is probably not even correct, but it's not that bad in practice. Yeah, so let's just do this. Mock out struct EP calls element point. I'm using the old LLVM terminology for this. It works fine. So, because I'm about to finish in about 5 minutes, and I may be back tonight, by the way, guys. So this evening, if you want to come in, that's fine. I've got other things to do at the moment, obviously, because got stuff to do in my life. Who'd have guessed that? And what we can do is actually just have a look at what this new like debug stuff is, because there should be debug record return. So he's including improving the record generation, which is nice. And then you end it. Because you create your struct, you put everything in, you create the fields, and then when you end it, it finalizes it, I'm guessing. You can also create a func. Now this is one of those things where there's not caching or anything yet. So if I go to Tilde, I think it's just Tilde Backend at the moment. Like here's, let's go for debug type. Where do I define that? Here. No, it's in statement apparently. I don't do anything. Which is nice to know. But I can create a function. I can set what the calling convention is. I set the parameter count, the return count, and that, and has args. So then this returns a pointer to a pointer. So that means, is that the thing I need to, no, that's a point, that's an array of stuff, isn't it? So clearly it's being worked on. So is it something like record begin? So we have to do the same, it's the same as a record in this particular case, maybe? I'm guessing, I don't know, it's not documented because it's still going to have to ask negate. But yeah, it's kind of a, figuring out what goes on. You've got to figure this out, don't you? And I'm just looking at the chat. This stream's been going on for an hour and 10 minutes, but again, remember to watch out for the next thing coming this evening, probably. I don't know when, I don't know, it'll probably, if I am streaming tonight, which I probably will do, it'll be in about 3 or 4 hours. Maybe. But yeah. So stay tuned for that. Honestly, it should be enjoyable after that. I also then have to figure out how to get this stream off the VOD to YouTube as well to get it on there, so people don't just get bored with the stuff. Reading through chat is always, it's annoying because again, these are big monitors I've got now. They're massive 32-inch monitors, 4K 32-inch monitors. Is like, they're a bit big. I have to swivel a bit, but doesn't matter. It's like a full-on cockpit, so it's like, whoa, yeah, whoa. Let me just say, it's fine for me. So I think we're gonna cool down now because I just want to look at what this was for the debug generation. I'm gonna have to speak with Negate later about this, how to improve it. So let's go to full camera and you get to see my lovely mug. And yeah, so thank you for watching everybody anyway. So if you've got any questions before I go, like I'll be gone in like 2 minutes now, please ask away, because this is quite fun. Yeah, I have 2 of these 32-inch monitors on my desk. But the 4K HDR, proper full HDR, I think 600 nits. So they're pretty decent. And mine, I'm about only, what, yard away. I'm doing the old-fashioned trick where you go from your nose to the thing, that's a yard-ish. So yeah, it's about a yard away, so only like, let's say a meter. But it's absolutely fine with my eyes. I've got decent eyes. I've had to scale up for the stream because it's so big otherwise. It's too small, otherwise you don't see anything. But I'm absolutely fine with the tiny text, and it's wonderful. But yeah, but thank you for coming to the stream anyway, guys. Really, yeah, it's wonderful. Yeah, like it was annoying. I wanted new monitors. The ones I used to have was like 27-inch, and they were decent size, but 1440p. I wanted to go to 4K because I thought, look, you know what? One, to future-proof myself. 2, actually, it's actually going to be decent to actually do development on 4K as well, because graphics nowadays, like kind of what I do for a living, like yeah, to make sure it all works on like HDR displays and 4K and all that crap, and it still works and scales correctly, and you take all the high DPI scaling nonsense, and so on and so forth. But yeah, But there we go. So I think I'm going to call that an end of a stream. So thank you very much for watching. I am probably going to stream again tonight, so please stay tuned for that. And goodbye, I guess. Yeah, let's do that.